Okay, so the last thing we'll cover for section 1.3, and then we'll be pretty much done with it, and you guys can really get into your homework and do the quizzing and whatnot, is to actually take a look at some evaluations. So I have 6 different evaluations. They have their own little unique problems and conditions, and so we'll take a look at each one. But the overall picture, remember what we're doing is we're taking an angle value and putting it into a sine function. So this would be very much like we did back in college algebra if I were to ask you to find f of 2, right? Of course, what you would do is you plug 2 into the function and find the output. Here we have a definition to use, right? Or we've memorized some values, but that's generally what's happening here. I'm giving you an input, and for that input, what's the sine giving you as an output? Right? What's the cosine giving you as output? What's tangent? And then of course now we're mixing and matching a couple of different values. So there's kind of the college algebra idea of what's happening. The other challenge here is 450 and 540 and 1800 and all these are not some angles that we've considered yet, right? The only ones that we've considered are the quadrantal ones. And that's good news for us though. Let's start there. It turns out that 450, if I subtract 360, right, and do some of the math there, I get 90 degrees. So we're back to the coterminal idea for this. So the sine of 450 will be the same as the sine of 90 degrees because of the coterminality. And again, here's the picture, right? So 90 degrees is right there, but 450 would go around a full rotation and then 90 degrees more. So that would be your 450. So they basically have the same point. I believe we use 0, 1 on the same side. So since there's the same point on the terminal side of these angles, that means whatever the sine of 90 is, the sine of 450 will be the same. And of course in the last video we found that the sine of 90 was equal to 1. Alright, so what's the sine of 450 degrees? It's 1. Okay, and so that's how we can basically handle some other situations and take advantage of the coterminality that we discussed long ago. 540, the same thing. What is this coterminal to? So if we, again start subtracting some full revolutions, we get 180. So again, picture-wise, 180 degrees is this kind of rotation. 540 would be that plus all the way back around. Alright, and so that basically means that the cosine of 540 is the same thing as the cosine of 180. And of course from a previous video we found that the cosine of 180 was -1. Right? I think we used the ordered pair -10 to do that evaluation in our definition. So the cosine of 540 degrees is equal to -1. Alright, and then here's a really big one, the tangent of 1800. All right, this is definitely probably one. Let's bust out a calculator, okay? But what I believe, what I think what we have. Let me as I think if we took 360 and multiplied it by 6, right? Let me make sure I got my math right. 6 and 6. Oops. Well, how about we just do this? Let's take 720 away because I know that's 2 revolutions. So 0. Excuse me. 7, that's 10, 9, 10, so 8, that should be 0, 1080. And if we do 720 more, 0, 6, 3. So basically 360, right? Or which corresponds to 0 degrees. So I just use 720 because that's 2 revolutions. So basically tangent of 1800 would be the same as the tangent of 0 or 360 degrees. And again, what we found, picture-wise, I mean, this is basically revolution. 1, 2, 3, 4, 5. We're basically going around 1, 2, 3, 4, 5 times, right? That would be 1800 degrees. It basically corresponds with an angle of 0 degrees. So the tangent of 1800 would be the same as tangent of 0, and what we found is that that's 0. So the tangent of 1800 is equal to 0. Taking advantage of the coterminality and our full rotation of 360. The next challenge is we have basically 2 different function values. Again, let me go back to college algebra. This would be very similar to if I was asking you to find f of 2 minus g of, let's say, 3. Right? The idea is I'd put 2 into the function value here and get some number, put 3 into whatever the function g was and get some number, and then subtract them in the end. So that's what's going on here in terms of a trig idea, right? So what's the value of sine at 90 degrees? We're going to get that value minus 4 times whatever the output of cosine is at 180. So that's essentially what's happening here. So the sine of 90, again, we know that to be 1, minus 4. The cosine of 180, we have it up there as negative 1. And so now doing the math, we got 1 take away negative 4, which is 1 plus 4. So that expression evaluates out to 5, all right, for the given values that were there. Forging ahead, some other nuances in this next one. We've got a lot going on. But more importantly, what we have, right, we're just looking at what's the tangent of negative 360, and then whatever that value is, we're multiplying it to pi. And then in the other one, we are squaring. That's going to be really crazy, right? The sine of 270. So again, that would be like taking a function, right, of a value of 2 and then squaring the result. And that's essentially what that means. So we essentially need to know find the sine of 270, square it, and then multiply it by 2. And so the sine of 270, when you go back, we found the sine of 270 to be negative 1. So I'm going to take that value and square it and multiply it by 2. Over here, plus the tangent of negative 360. Well, this is coterminal to the tangent of 0, right? Which we know to be 0. Okay, from some work we just did. So basically, that's what we have. So the tangent of negative 360 is 0. The sine of 270 is negative 1. We put them in the expression and just keep moving forward. So order of operations, we have 2 times 1. Pi times 0 is 0. And so the net effect, that expression evaluates out to 0. And we're finished. All right, the next one has some other little nuances. This one's kind of weird, right? Because we're taking the cosine of 90 degrees plus 180 times n, where n is any integer. So unfortunately, what makes this one really challenging, unlike the ones we've been doing, you know, the input's not fixed, right? Right here, the input was fixed. We figured out where we were at, found the value, right? The input was fixed. We found the value, went from there. The input was fixed. We found the value, went from there. Here, the input's constantly changing, right? Because as n changes, so is the input. So we better, before we start finding what the cosine value of it is, what's the input? So let's do some experimenting. Right, when n is equal to 0, right, that's going to be 90 plus 180 times 0, which is basically 90. So our first value is the cosine of 90, right? This is when n is equal to 0. What about when n equals to 1? Well, if n equals to 1, we're talking about 90 plus 180 times 1. And I believe what we get is 270. So the next value we're interested in is the cosine of 270 degrees, and that's when n is equal to 1. And then let's just keep going. When we let n equal 2, we get 90 degrees, 180 times 2. I believe this is 90 plus 360, right, which is 450 degrees. Okay, and as we saw earlier, we can already start seeing a pattern. What do we know about 90 and 45 degrees? You can actually see it there. They're coterminal. All right, and so it looks like as we keep going forward, right, we're going to be coterminal to 90 degrees, right, as we keep moving forward. If I can go one more, n equals 3, this is 90 plus 180 times 3, right, that gives us 90, I think 0, 6, 1, 460, and then I think that gives us 540 degrees, right, but we knew from some earlier work, 540 degrees is coterminal to basically I believe I think I did my math wrong there. Let me do this right one more time. 0, 4, carry the 2. There we go. And then 90, 0, 9 and 4 is 3, carry the 1, 630. I believe 630 is coterminal to 270. So that would be the next one. And so you can kind of see a pattern starting to present itself. Yes, as n gets bigger, right, or heck, if n was negative, right, we're going to have different values, but it seems like they're constantly, right, this one and this one are the same because of the coterminality. This one and this one are the same because of the coterminality. So basically, right, if we can find the value of these two, we found the value of them all. What do we know about the cosine of 90? Well, it's 0. What do we know about the cosine of 270? It is also 0. So basically, this thing is always equal to 0 because the input is going to be coterminal to 90 or 270 degrees. So that one was quite difficult to hopefully kind of understand the reasoning and how we kind of went through that. And it basically came down to our ability to find the values of our quadrantal angles. All right, so that should get you started. I think we've wrapped up all the different homework ideas, all the definitions to section 1.3. If you have questions, please ask. Jump on Canvas and get the conversation going or some points. Ask for an office hour, email me, whatever it takes. All right, I'll see you guys in some Canvas discussion boards.